Integers. In this module, you will learn about integers, operations on integers, properties of integers, and some practical problems using integers. We have learned that 1, 2, 3, 4, and so on counting numbers are called natural numbers. By including 0 to the collection of natural numbers, we get a new collection of numbers called whole numbers. If we add negative sign before natural numbers, we get -1, -2, -3, and so on, and they are called as negative numbers. Now, if we put whole numbers and negative numbers together, we get a bigger collection of numbers called integers. It is denoted by capital Z. It is represented on number line as the absolute value of an integer is the numerical value, without regard to whether the sign is negative or positive. On a number line, it is the distance between the number and 0. The absolute value of -7 is 7. The absolute value of +7 is 7. The symbol for absolute value is to enclose the number between vertical bars such as -20 equals 20 and read the absolute value of -20 equals 20. Observe the addition given below. We will find that when the number being added is decreased by 1, then the value of the sum goes down by 1. If we observe it on number line, when we add a positive integer, we move to the right. Add a negative integer, we move to the left. Now let us study the subtractions given below. We will find that the number being subtracted is decreased by 1, and the value of the difference goes up by 1. If we observe it on number line, when we subtract a positive integer, we move to left. Subtract a negative integer, we move to the right. Now let us multiply integers. We know that multiplication is a repeated addition. Example, 3 into 4 equals 4 plus 4 plus 4, that is 3 times 4. Thus, 3 into 4 means 3 jump each of 4 steps from 0 towards right on the number line. Thus, 3 into 4 is 12. Now, what is 3 into -4? Let us see. Here, 3 into -4 equals -4 plus -4 plus -4, that is 3 times -4. Thus, 3 into -4 means 3 jumps each of 4 steps from 0 towards left on the number line. Thus, 3 into -4 is -12. Now let us multiply -3 into 4. See the following pattern. We see that as the multiplier decreases by 1, the product decreases by 4. Thus, from this pattern we got the answer -3 into 4 is -12. Also, already saw that 3 into -4 is -12. Thus we can say -3 into 4 equals to 3 into -4, which is equal to -12. And we notice that product of a positive integer and a negative integer is always a negative integer. Now, what if we multiply -3 into -4 and -4 into -3? Let us see. Here, when we multiply -3 into -4, we notice that as the number of times we multiply goes down by 1, the product increases by 3. And when we multiply minus 4 into minus 3, we notice as the number of times we multiply goes down by 1, the product increases by 4. And lastly, we get minus 3 into minus 4 is equal to minus 4 into minus 3 is equal to 12. Thus, every time we multiply two negative integers, the product is a positive integer. What if we multiply three negative integers or four integers or 5 or more? Let us see. From this products, we can say that the product of three negative integers is a negative integer. The product of four negative integers is a positive integer. The product of 5 negative integers is a negative integer. The product of 6 negative integers is a positive integer. Thus, we find that if the number of negative integers being multiplied is even, then the product is a positive integer. And if the number of negative integers being multiplied is odd, the product is a negative integer. We know that division is the inverse of multiplication. Now we know that 3 into 5 equals 15. Therefore, 15 divided by 5 equals 3, or 15 divided by 3 equals to 5. Thus, it says that for each multiplication statement, there are two corresponding division statements. What if we divide integers? Let's observe. Multiplication statement and the division statement. From the table, we observe that when we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. We thus get a negative integer. We also observe that when we divide a positive integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. That is, we get a negative integer. Lastly, we observe that when we divide a negative integer by a negative integer, we first divide them as whole numbers and then put a positive sign. That is, we get a positive integer. Now we will study the properties of integers under addition. Is the sum of two integers always an integers? Let's check. We see that by adding two integers positive or negative in each way, we get their sum as an integer. Therefore, integers are closed under addition. Is the addition of integers commutative? Let's check. From this, we observe that for every pair of integers, their sum remains the same when the order is changed. Therefore, addition is commutative for integers. Is the addition of integers associative? Let's check. We find that the sum in each case is equal. Therefore, integers follow the associative property under addition. On adding 0 to integers, do we get the same integer? Yes, you do. Therefore, 0 is the additive identity for integers. Have you noticed, do we always get an integer when we subtract an integer from an integer? Let us check it. Yes, we can see that we get an integer only. Therefore, we can say that subtraction of integers follow the closure property. Now let us check for commutativity of subtraction of integers. Consider this example. we see that subtracting two integers in any order, the difference is not the same. Thus, subtraction is not commutative for integers. To find out whether multiplication of integers is closed, let us see the following examples. We see that for every pair of integers, their product is also an integer. Therefore, integers follow the closure property of multiplication. Is multiplication commutative for integers? Let us check it. Multiplying in any order of pair of integer, the product remains the same. Therefore, multiplication of integers follows the commutative property. Now consider the multiplication of 3 minus 4 minus 5. Grouping in as follows. In first case, 3 and minus 4 are grouped together, while in second, minus 4 and minus 5 are grouped together. For both, we get the final product as same. Hence, the product of three integers does not depend on grouping of integers. Therefore, the multiplication of integers is associative. Let us see if multiplication is distributive over addition for integers. Let us see some example. We see that in each case, the left-hand side is equal to right-hand side. Therefore, multiplication distributes over addition. We know that 0 is the additive identity for integers. But let us check for multiplication. We find that multiplying an integer by 1 does not change the integer. Thus, 1 is called the multiplicative identity for integers. When we multiply any integer by 0, do we get 0? Let us check. So this shows that product of an integer and 0 is 0. Let us now check the properties of division, if we see in the following table. In the third case, we do not get the result as an integer. Therefore, we can say integers are not closed under division. Let's check whether division is commutative or not. If we see in this table, we notice that if order of integers is changed, the result is not the same. Hence, we can say that division of integers is not commutative. Like the whole numbers, any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. We have seen that when we divide a whole number by 1, we get the same whole number as quotient. Now, is it true for a negative integer also? Let us check it. Thus, we see that a negative integer or positive integer divided by 1 always gives same integer as quotient. Therefore, 1 is the identity in division of integers. Let us summarize all that we learnt in this module on the integers.